Hey there, welcome back to my channel. So today we are going to work on our catalog service. In the previous episode, we have covered how this agile process is working, and we have seen pretty much like in a practical way how we can create the story and how we can estimate that specific task, or we can figure out like how much time gonna take for one specific functionalities, right? And now this is the time where we will be put our hands on the coding part. So let's try to create the first microservice that is called catalog service, right? So here in this diagram, we can see we have two microservices, right? Catalog and order. So we are going to create both the directory and we will be keeping both the microservice in one workspace. So at least we can simultaneously switch it back and forth to work together, right? Though we are keeping both the microservices in workspace, still they are going to follow their own GitHub repository, own set of deployment rules, and etc. Right? So let's try to do that. So let's go to Visual Studio Code. I'm gonna open this terminal, right? You can open the terminal, go to here in the terminal and click on the new terminal, right? This is my root directory where I'm gonna create both the microservices here. And in my case, I'm gonna create a bunch of directories that is called mkdir, catalog service, order service. These are the two directories, right? So let's go to inside this catalog service, and then here we are going to init the Nodejs project, init y, here on at express and nodemon express. As dev dependencies, right? Here, this is the first step we are doing, right? And a couple of more things we need to do. That is called yarn add typescript. Yeah, typescript ts node. So these are the things we need to install, right? Let's add it. Cool. Now let's go back to our root directory. So now we can see we have two directories here, right? So similar thing we can do, like maybe go order service and npm, at least npm init we can do, right? Cool. Now here we can see both the directories are exist in the root directory, right? In the recording directory. So potentially what we need to do, we need to add both the microservice to one single workspace. So let's try to do that. Let's go here and go to file, add folder to workspace, right? Now add here. Here you can see this is my path where I have just created both the directories, right? So let's select both the directories and click on open. Now you can see both the projects are added to the workspace, right? So let's go ahead and save this workspace. So file, click on the file and save workspace as. This is going to be like here in the root directory, a recording here. I'm gonna keep it Kafka Elasticsearch microservice, right? So let's try to save this one. So now if you go here, open that specific workspace, then you can find it out. So here in the recording, so this is my workspace. If you double click, then it's going to be open like this, right? Now, and here you can see in my workspace file, we have only two directories. That is called the catalog service and order service. So though we are keeping both the services together, it'll maintain their own set of the file path accordingly, right? So that's the beauty of the workspace. Here inside the catalog service, let's create a couple of directories. So first directory we are going to create that is called source, src, because we want to keep all this source file in an organized way. So let's try to create one more file that is called server.ts. So this is our entry file, but as you know, we are going to write the codes in the TypeScript, so that definitely the TypeScript configuration file is going to be needed. So let's try to initialize the TypeScript configuration file here. So this is going to be tsc dash init. You can see our TypeScript configuration file has been created, right? And let's try to close this one here. And now what we are going to do, but right before adding the codes, what are the things we need to create? That is, we need to determine, right? So let's go to the diagram once again. So here in the catalog service, we know what to do, but still we need to have a more clarity on how we can segregate, how we can add some kind of the system boundaries and between these two microservices. That is, we need to figure out, right? What exactly the system boundaries? To identify the system boundaries, we need to apply the DDD, right? So with the help of DDD only, we can figure out like what are the physical and logical boundaries are there, right? So some of you already familiar with the domain-driven design, right? So what is domain-driven design exactly, right? So still, I don't wanna make you bored, but still some of you are maybe not familiar with the domain-driven design. So I just wanna do a little bit quick recap. Let's have a look at the domain-driven design. So in the first question is like, what is domain exactly, right? So in this case, you can say, so domain is a kind of business. You can say like e-commerce, e-commerce application, right? You can say e-commerce is a kind of domain, right? Or you can say finance, you can say banking is a kind of domain, right? And another thing you can say like, the shipping is a kind of domain, right? So these are some of the examples of domain, like where e-commerce, finance, and shipping, these are domains. Perfect. So now we got understanding of the domain, what exactly it is. It's a kind of certain type of business or type of some kind of like attributes, which is we are going to use as a kind of maybe source of that specific application, which is we are going to design. What this domain-driven design is exactly helpful for, right? So now let's try to create one single example here. This is going to be, I'm going to say like iPhone, right? So this iPhone, maybe for this product expert, or maybe you can say domain expert, and here we are going to add in developers, or here we are going to add our, or maybe project manager, you can say. So this iPhone exactly, it's a kind of it's a kind of normal item, right? So which is a kind of part of maybe e-commerce application product, right? So you can see here this iPhone can have, this domain expert can have, they may it's gonna say like iPhone is a kind of electronic product. Developer maybe can say like product, or project manager say maybe electronic item. This iPhone is a kind of product which is going to be different name for the different peoples. As an example, domain expert who are exactly expert in the e-commerce domain, they are saying it's an electronic product, right? And then developer can say it's a kind of product, right? And project manager say it like, yeah, it's electronic item, maybe more item can come, right? So you can see different terms for different people, but all these people, they need to work together, right? So this is what the domain-driven design it is trying to solve, right? So what domain-driven design it is trying to say, domain-driven design is about to finding one and only language that engineers and the business domain expert can use to communicate with each other, right? That is called ubiquitous language. Perfect. So now let's try to define a kind of name or some kind of attribute for this iPhone with the help of the ubiquitous language. Just like you can see this electronics product it's a kind of product, all right? Or developer also it's gonna say it's a kind of product, or product manager also has to be define it's a kind of product, something like that, all right? So let's try to give it as a kind of name that's called phone. Phone maybe iPhone, or phone maybe a kind of like maybe Android or maybe Windows phone or something like that. I'm not going to pretend it's a kind of the specific term to say how we can say by everyone, but in this case, let's assume it's a kind of phone. You can say it's a phone, or here also phone, right? So then everyone can decide like it's phone is a kind of product. It's fine, perfectly fine. What kind of product? Maybe it's iPhone, maybe Windows, or maybe Samsung, or it doesn't matter what kind of brand it is, but at the end of the day, it's a kind of phone. So everyone can have a kind of common understanding of that specific thing. This is how domain-driven design it is helping us to figure out the common vocabulary for working together, right? Now let's try to define the system boundaries with the help of domain-driven design for our e-commerce application. So in this case, so how we can figure out e-commerce application can have what? E-commerce application can have, right? So let's go ahead here. E-commerce application can have a product, right? So which is going to be potentially, it's a kind of catalog, you can say, right? Where you can get the information about the product. Information about product, right? And another thing we can have maybe categories. And one more thing we can have, what? It's going to be like in a price, right? Price. Now let's try to find out what are the things we can have. Let's try to figure out the product catalog we can have. Now we can have a customer, right? Then customer can have what? The customer can have their profile, right? And customer can have their cart, right? And then customer can have orders also, right? Right? Perfect. So now we have our customer. Now let's go ahead and add it here as a kind of payment, right? Payment information is going to be needed, and payment can have transactions, right? Transaction can be success or maybe fail or whatever it is, and transaction can have orders, right? Which order exactly they're collecting the payment, something like that. So you can say it's a kind of very basic idea to find out the system boundaries, right? So we can say product, we at least minimum we should have to have a product where can we have categories, information and all. And after that, customer is going to be needed, which is going to act as a kind of buyer, right? And we need to have the payment. And one more thing is going to be needed in terms of, like, you can say inventory can have the sellers, and sellers may be a kind of user also, right? Then customer also going to be user. So you can see, like, this is a kind of totally messed up, right? So you don't know, like, which exactly portion we need to move it. You can see the customer can have orders, order can have products, right? And payment can have orders, and again order can have a product. So there is a kind of, like, it's a kind of bond is happening, there are some kind of relations are happening throughout of the whole, all the services in terms of, like, all the features. That is how we can fulfill the e-commerce application, right? Now let's try to figure out how we can define the boundaries, right? Here we can see there's a kind of some kind of, like, hypothetical boundary we are just created here, which is you can consider as a kind of context for each service, right? So user can have their own isolated scope where we will keep only the user related information, just like, profile or customer, some kind of, like, in the sensitive informations or some services stuff, which is we can keep it here in the customer, the user context, right? And in the catalog also, we are going to store the same kind of stuff, which is going to be needed for our catalog only, like as an example, the product or category or some kind of the product information, right? This is our catalog context, right? So this context exactly you can say it's a kind of bounded context for microservice, right? Where we are going to isolate its models, operation, and the interactions within that specific microservice only. We don't have direct access of anything from outside of the context, right? So that means our model only responsible to perform that certain operations for certain microservice only. So this is how we are segregating this stuff. Now the question is, like, how each and every microservice can access their other microservice context data, right? So in that case, because if we are keeping, like, you can see if we are directly accessing this one, right? If you're directly keeping reference to that the catalog context, right? Then there's a kind of tight coupling going to happen, right? So in this case, it doesn't matter, like, if we are going with the microservice architecture also, end of the day, we are just ended up with, it's a kind of distributed monolithic, right? A monolithic application we are try to deploy in different server, but behind the scene, they have a kind of tight coupling. So we will not be able to achieve to the pure microservice architecture result, right? So this is we are not going to do in this case. So what we are going to do, we are going to access the data, all right? Access the data with the help of some kind of event, all right? Which is already I have explained in my couple of my courses in different playlists. But again, we can say here in terms of while the microservice is going to talk, where some data is going to need it or some operations need to perform with the another bounded context, then we are simply just firing some kind of event. You can say the fire and forget, right? Or we can use some kind of event just like message broker, right? It can be like maybe SQS, it may be Apache Kafka, or maybe RabbitMQ, and anything, right? But here, this is how we are defining the system boundaries. So user can have its own responsibility, catalog can have own responsibility, and order can have own responsibility, and the payment can have their own. But you can see, like, here also we have a product, right? And here also we have a product. So this is the thing exactly domain-driven design is to try to figure out each and every context, right? Maybe different contexts can have their same type of models, but it can be different meaning. It can express different meaning, right? So here you can see in order context we have a product, right? But product meaning is only ID, title, and price, right? But here in the catalog context, you can see the product has a different meaning. We can have like ID, title, description, stock, price, availability, images, a lot of things, right? So in the order context, we are going to deal with only those meaningful data for the product model, whatever not going to conflict with the other model, other context, right? This is how it is working. So we are never gonna update this product stuff from our catalog context, right? So in this similar case, like we are not going to update anything from order. So here, maybe if you are comfortable, then you can go ahead, maybe you can segregate this context to a kind of inventory context where we are exclusively only we are updating the stock, price, availability, something like that, right? So this is how we are finding out the system boundaries. So at least we don't have a kind of conflict between the microservices. We don't have a kind of direct access or tight coupling between the microservices. This is what exactly domain-driven design is like, guiding us to build such a kind of things with the help of loose coupling. I think it's pretty much clear at this moment. I'm not gonna make you bore anymore because it's a lot of talk. But I know this kind of concept, when we are putting hands on the decoding part, then we are not considering at all. We are just like doing decoding, get the job done. But end of the day, while it is come to the scaling, while it comes to like the figuring out the dependencies, loose coupling stuff, then definitely we are falling the trap, right? If we are not considering our stuff like this, right? Cool. If you guys are interested to learn more deeper in the domain-driven design, I would like to encourage you go ahead and read this book, which is written by Eric Evans. I am personally finding this book is very helpful for me, right? Let's go ahead and deep dive into the source code now. So as we discussed, we are going to follow domain-driven design, right? Let's start with the domain. So here what we are going to do, we are going to create a kind of directory that is called new folder, and it's going to be model, right? In domain-driven design, domains can have multiple models, right? And model will be responsible to take care of certain business logic and etc. So let's try to create our first model. This is going to be like the product.ts, right? And let's try to add some code here. Export class, right? Product. Add some property to this class. So first of all, let's create a constructor, and it will be a kind of empty constructor. But here inside the constructor, we can add the public property, or maybe you can just go ahead and just like this, public name will be string, right? Something like this, string. Here in the TypeScript, by default, all the properties are public. So we no need to explicitly say it's public, right? You can just keep it like this, but we're not going to follow this pattern. We are going to do like this, right? Public read only name, right? So why we keep this public attribute right here? So we are defining our properties here while we are initializing our constructor. So that's why we need to add public right here, because we want this property to be public, right? But in the constructor scope, if while you are initializing, if you're not putting this one, it is going to be remain private, right? So this is the thing we need to do. And second thing, like let's go ahead add one more property that is called price, right? Price, and price going to be a number, right? Number, read only. This is going to be stock will be also number, and public read only. This is going to be optional. ID going to be optional. This is going to be also number, or you can add description as well as. So let's try to keep like here, public read only string, right? So these are the properties are needed, right? And make sure like we may have some kind of property, which is we are going to, maybe we don't need to initialize at all. So to get rid of that warning, you just to go ahead here in the tsconfig file and make sure find the strict property initialization one, right? So this one, we are going to set it as a false, right? And another thing we need to do, because we are going to run this whole application on Docker, so then we need to compile this whole TypeScript stuff to our common.js. So in that case, let's try to figure out where, yeah, this is our root directory, and we are interested in our source directory only, right? Source directory. So while we are going to compile anything, you know, from the source, then we are only interested in the source directory. So in future, maybe we will add the infrastructure also, maybe some other directories, then we are going to separately deal with all those things. So let's keep it this way. And while we are going to compile our stuff, all right, as an example, if I'm going to compile this stuff here, tsc does tsc does p dot, right? So this is the syntax exactly which is going to compile our whole TypeScript stuff to a kind of common.js, right? So if I'm going to compile this one, you can see like it's compiled successfully, but it has generated the files besides the TypeScript file, which is we don't want, because we don't want to deal with all these common.js files, right? So let's try to delete all these things from here. What we are going to do, we will be add some kind of configuration here that is called outdir. Right after the compilation, it's going to be create a kind of directory and put all these files together in the similar structure of the directory, right? So let's try to do that. In this case, we are putting as a kind of distribution directory, right? Now, if you are going to compile this stuff, then it will create a kind of distribution directory. Can you see? It's created. And we can have this similar structure, just like we have the server and models and everything. This is how it will gonna work, right? So let's close it from here. And one more thing we need to do, because in coming lectures, we're gonna use some kind of like inversion of control also. So in that case, we need to enable two things that is called experimental decorator, right? This one, right? And this is exactly, it's not required at this moment. Let's try to enable this one. Now I think we are done from the settings part. Our model is ready. So this is our domain exactly at this moment, right? So how we can deal with this? Now let's try to expose our domain, right? With the help of some kind of the data access layer. So let's try to create that. Now new folder, this is going to be repository. Repository is a kind of data access layer, which is we are going to use to expose our domain stuff, right? So let's try to create new here, like catalog repository.ts, right? So what are the things we can add? So in this data access layer, we need to test it also, right? So this time we are going to follow some kind of TDD pattern as well as. So to follow that principle, right? So at any point of time, this repository should have to be replaced with some mock repository also, right? So at least we can successfully evaluate this domain stuff, right, with the help of that specific mock repository also. So how we can do that? So let's try to create one more directory that is called interface, right? Interface, right? So let's try to create one interface here. This is going to be catalog repository.ts. So let's try to add some code here. All right, so let's try to add some code here. This is going to be create. And this is going to be data, can be any at this moment, right? And it's going to return something like we can say return a kind of promise, and promise can have any object at this moment, right? We can decide what kind of data we are going to fulfill right there. And let's try to add a couple of more. That is going to be our update. This is going to be update, right? Then delete. All right. And then this is going to be like find like this. Promise. This is going to be kind of array, right? And find one. ID any. It's going to be number maybe mostly, and it can be promise. It can be a kind of object. All right. So now our interface is ready. So I'm gonna explain why exactly this interface is needed, right? Because we could have done the whole repository here, but in terms of while it is coming to the test-driven development, right? Or you need to test it out with the help of some kind of the mock stuff, which is we are going to inject it from somewhere else. Then interface is extremely necessary to match with the what kind of object we are going to pass the through out of that thing. Perfect. So now our interface is ready. So let's try to implement this one here, right? Go to catalog repository, export class, catalog repository, implements, hi, catalog repository. Right. So let's try to implement the whatever the interface methods we have already declared here. Let's try to implement here. So implement. So now you can see our catalog repository is perfect, right? So at any point we can just come over here and we can replace this catalog repository with something else also, which is going to comply this specific interface, right? Where create, update, delete, find one, etc. So now it seems our domain stuff it is going to be fulfilled, but we have not utilized all this domain stuff here. So in the promise we can move forward with this like catalog model or product model, product model, right? Product, right? And data will be something like what kind of data we can put, like product, right? And it is going to create the product and return the same kind of product also, right? And update also we can do the same thing, right? Product and return going to be product. And here delete also it's not required, but the find the promise this is going to be something like product, and here also product. Perfect. So now let's go to catalog repository. Here also we can implement the same thing, right? Let's try to quick fix. Yeah, now it is complying perfectly. This is going to be wrong exactly. There's a kind of spelling mistake maybe. So let's try to interface. This is going to catalog. Okay, cool. Repository, perfect. Now our repository layer, data access layer is perfectly fine. So it is going to be work perfectly with us. Now let's try to create one more thing that is going to be our service layer, right? Which is where this repository stuff is going to expose with the help of like service. So service layer essentially it is a kind of layer which is going to handle our business logic. So let's try to create that directory as well as, right? So services, you can say in another term, it's a kind of use case also, where all the use case in terms of all the business logic we are going to add it here, where it will find while we are creating the product, it will check it out whether the product is exist or not, right? So find out the product exist or not. If it is exist, right, then maybe update the stuff, right? Or maybe if it doesn't exist, then create the stuff, right? So let's try to add more file. This is going to be our catalog.ts, right? Export class. Catalog service, and here we are going to create a couple of methods. That's going to be first create product, which is we are pretty much in terms of like the specific. Here in the repository you can see we are not specific, right? Repository is only responsible to perform that data operations, which is maybe create, update, delete, or whatever, right? But in the service layer, we should have to be specific, like what we are going to create. We are going to create product. What we are going to do, we are going to create a category or whatever. So in this case, we are going to add some kind of the input also. Let's put some kind of any here at this moment. Maybe update product, which is going to input also any, but we will be creating the DTO files also, right? Which is going to transfer our user request to some kind of the meaningful data. That is in a second we are going to create. Let's try to add a couple of more methods. That's going to be like retrieve product, or maybe fetch product, right? Or you can say like get products, right? And where we will be put some kind of offset. It's going to be limit number and offset. So this limit and offset is extremely necessary while we are dealing with a massive amount of data. So at least we can have flexibility from the front end or maybe from the client. This much of the data range we need. So it is reducing the query load from the database, right? So that is we are going to do here. And now let's try to get the similar thing here. This time it's not going to be products. It's going to be get product. And we know it's singular, all right? So that's why we need to provide some kind of the ID here. So only we are looking for one product, right? Then delete product as an example. The product ID. Right. Perfect. So now seems like all this necessary information, whatever exactly needed here, that is we have added, right? But how we can hook up all these things with the repository? So let's try to create our constructor, which will carry our repository. This is going to be repository. Repository will be our I catalog repository. And here also provide like a repository. This is going to be private because by default in the TypeScript everything is public. So private. We don't want to expose our repository to our any of the classes outside while we are creating this instance, right? So let's try to create like private repo will be, we can put like in a short name also here, but it's fine. It's up to you like how you can define the naming convention. So in my case, I'm just putting us like this, right? Or maybe let's go with the try to be consistent a little bit here. And this is going to be I catalog repository, right? And here this repository will be repository. So now our repository we can access from our any of the functionality from here, all right? So in this case, you can see this repository, it's a kind of I catalog repository. So if you are going to create one more repository here, as an example, mock repository catalog repository .ts, right? So in this mock catalog repository, if we are going to implement the same thing, right? And let's assume, right, here, this is going to be mock, and we can compile the same thing here, right? Yeah, cool. So now here in the catalog service, you can see we are only using like a type of repository interface, right? So whatever the repository is going to comply this specific interface, then we can just pass it accordingly here, right? So that means while we are writing some test cases for our catalog service, then definitely we no need to test all these things like the actual repository. Instead of that, we can just pass the mock catalog repository from here. That is how it's gonna work. So now let's step forward once again from the service layer, right? So we have our the models, right? We have our domain, we have our data access layer, we have our service layer where we are writing business logic. Now let's move forward to presentation layer where we are going to expose all these things to outside world, like maybe to the client. So in this case, this is going to be API, right? And API can have different directories in terms of like maybe GraphQL, GraphQL, or maybe it can have a REST, all right? Anything it can be, all right? So in this case, we are not going to create too many directories because we are not going to implement GraphQL here. It's going to be only RESTful API. So let's try to create a couple of the API routes here. That is going to be catalog. Yes. Perfect. So let's try to add some code here in the catalog routes, right? Before that, we need to install Express, right? Let's go to package.json file here. Let's check it out. We have Express, but we need the type definition file as well. That's right. In the dev dependencies, we need to install the types file. So let's try to add that. Right. Now let's add some code here. First of all, import Express from and then after that we need to export default the router, so at least we can utilize in our server file, right? So let's try to add some kind of endpoint here. And we need one more that is called next, because at any time this specific endpoint can throw error, so at least we need to handle that specific things in our top level of our service right here in the server.ts file. Then it is going to be next function, right? And let's try to return something from here. So let's try to go ahead and implement the server here. The server is the entry point of our microservice. In the server file, the server can have a multiple server. It can be GraphQL, it can be RPC, or it can be HTTP server, right? So in our case, we are going to create HTTP server. So let's try to create an HTTP server. That is, we are going to take help of our Express. So let's create the Express app here. .ts. Here in the Express app, let's try to create Express. So here, this is the code snippet which is I'm using at this moment, and it's a kind of user snippet which is I have created from here. Click on the code and click on settings and click on configure user snippets, and here select this one that is called a new global snippet file, which is globally it's gonna work for your IDE, and select that one, put a name as an example snippet, snippet, and you can just uncomment this piece of code here. It says like print to console. In this case, let's assume router, right? Then router, and we are going to create a simple router just like router.post, and this is gonna be like this. So make sure you're escaping this special characters, just like the quotations. And after that, you can say like a res request res. All right. And return will be res.json. Something like this. It's a kind of like example the snippet. Segregate to a single file, single line, like this, like this. Let's keep a name is a kind of different name, example pd snippet, right? So now let's try to check it out here. Example snippet, if you're gonna put like, it will going to give you like this. This is the way I have just created my snippet here. Let's put a kind of port number at this moment for 8000, right? Just to work it out everything correctly. And here, let's try to parse the JSON. And afterward, let's try to remove all these things from here. And here, app.use, we need to import our router. That is going to be like So now our Express app is ready. Let's add some code in the server. In the server, simply export const. Server will be like this, but this is going to be async because we need to initialize our database. We need to initialize a lot of things in terms of like maybe Kafka, Elasticsearch, everything. It will be get inside. So all those async operation, all those operations going to be needed asynchronously. So let's mark it as kind of async here. And now here, Express app. This is we need to import here. Maybe we have not exported yet, right? And let's try to export that thing. Export default app. This is cool. Now here, let's try to import Express. Listen to port number, whatever the port number we need to assign, that is going to work. So we are going to get rid of this line because this Express app also we need to test it out, right? So then it doesn't make sense to here keep it this one here, right? So let's move this port, that specific line of the port. Here we will be putting here the port. Then listen to port. Right, cool. Then we need to handle the exceptional as well as. So where if anything is come up like our Express app is not responding at the time, we need to restart the application also. That is we can do like this. Press on right? Then if anything is come up over here which is not going to handle it at all, at that time we need to just restart the application, right? So this is how we are just doing it, this one. So now our server is ready. Let's try to start the server. Start server, and then we can say server is up. Cool. So now we have set up everything, right? From our domain, from our repository service, and our APIs, and our HTTP server as well as, right? And finally, we're just starting out here. So let's try to add some script here. That is going to be Dave, and where we are going to start like nodemon src and dot server.ts. While we are starting our production version, then we need to say start, and this time we are going to give the production build directory that is called dist, right? Node, then dist, then server.ts. That specific directory we have the server.ts JS file, right? So and this is JS, exactly. Sorry, it's JS. Now everything is good, right? But we need to compile it. Let's try it first. So let's run this development version. That is now yarn dev. Perfect. So now this app is running on localhost 8000, right? So now if you go here, right, let's try to make a call. So in this case, how we can make the call? Let's try to create a kind of HTTP file, HTTP request. HTTP, right? And here post colon 8000, and this is going to be product. So do you have the product? Yes, we have the product, right? And product, and the content type will be application JSON, and we can have like this, some name will be, let's say, right, just a kind of sample request. So how we can get this specific requesting here in the Visual Studio Code, as you can see, I've just created one HTTP file. That extension you can get it from here. You go to extension and you just put it REST client, REST client. So this is the plugin which is I have just installed, right? Which is going to help you out to make all these calls from your Visual Studio Code, right? Perfect. Let's have a try from here. Now you can see I've received the empty response from here, and it says like 201 that is created, which is we are returning from our API. Perfect. So now our development version is working, right? Let's try to compile the code and try to run the production version as well. So in this case, we need to build the product, right? So to build it out, go here in the package.json file and add the build command here, build, and right. So tsc-p and dot, exactly it is signifying that the specific root directory, right? And here let's try to run that build command here on build, right? Now build is done. If you go here this distribution directory, then you should supposed to see the similar kind of structure here. You can see this is the similar structure, and all the source code has been converted to common.js at this moment, right? And now we can purely run this yarn start, right? It's running it once again. Now here, if you go to here in HTTP request, click on the send request, then you should supposed to see like this one. Now you can see this is the similar kind of response we are getting it. All right, perfect. So I think for this episode we have covered like how we can segregate the system boundaries and all, and basic setup of the project. In the next episode, we are going to put our hands on TDD, where we will be writing some kind of the test based on our business logic, right? And we are going to simulate the service, repository, and everything together, right? So we will follow strict like a test-driven development model. So that's all for this episode. In the next episode, we are going to purely focus on the code, where we'll be putting our hands on the test-driven development, where we will be writing a lot of test cases and the business logic. I'm committed to deliver the quality content, and if you have not subscribed to my channel, subscribe it right away. And because from the channel, you will be getting a lot of practical, useful knowledge throughout of the whole series. Right, perfect. Then I'll be looking forward to you in the next episode. And till that time, bye-bye.